Good afternoon, class. My name is Dr. Araypur. Here's practice test number 2, module 2, covering chapters 4, 5, and 6. Chapter 4, systems of equations and inequalities. Chapter 5, chapter 6, polynomials and factoring. So first we have a definition. If the system of linear equations results in two parallel lines, the system is inconsistent with no solutions. If the system of linear equations results in two intersecting lines, the system is consistent with a unique solution. And if the system of linear equations results in a single line, the system is a dependent system with infinitely many solutions. To elaborate on that, I want to remind you of what we did. Here's a consistent system. If you graph, there is a point of intersection, and there is precisely one point of intersection. If you solve for y, we get different slopes. So the system has a single solution at the point of intersection. The graphs are different. They have different slopes. Inconsistent system, the system has no solutions. The graphs are parallel lines. They have the same slope but different intercepts. So if we were to graph them looking like that, if we were to solve for y, they would have the same slope, different y-intercepts. Also, if we were doing it by the substitution or addition method, what do we end up with? We would end up with a contradiction such as 0 equals 7, 1 equals 5, things of that nature. A consistent system with the dependent equations, the system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. In essence, when you graph them, it's a single line. If you were to solve for y, you get identical equations. Slopes are the same, intercepts are the same, and we have infinitely many solutions. So if we are solving it by the method of substitution or addition, we end up with an identity such as 0 equals 0 or 5 equals 5. We want to solve the system of equations. We can do it by any method. In this case, addition will do the job. If you want to get rid of the x, you can multiply this one by 5. If you want to get rid of the y, happen to be the same. So let's multiply the top by 5. That results in minus 5x plus 10y equals negative 5. And you just repeat the second equation unchanged. I hope you notice they cancel each other. They cancel each other. So 0 equals 1. This is a false statement. Therefore, we have an inconsistent system with no solutions. In other words, if we were to graph, we would end up with parallel lines. Now, if you want to get rid of the x variable, you can multiply this one by 5, this one by 2. If you want to get rid of the y variable, you can multiply this one by 3, this one by 7. It is your choice. If we multiply by 3 and 7, here's what we get for the first one. So multiply 3 by both sides of the first equation. You get 6x minus 21y equals 9. Multiply 7 by both sides of the second equation. You get negative 35x plus 21y, and the right side is 49. Clearly, these two cancel each other. So we have 6x and negative 35x. They end up with negative 29x. 9 and 49 give us 48. My apologies, 58. Divide by 2. We divide by negative 29. We end up with negative 2. Now we go back to one of the original equations. For example, the first one, 2 times x. So 2 times -2 minus 7y equals 3. And this is -4. Moves to the other side, becomes +4. 7 divided by -7. Y is -1. So it's a good practice to put them as a pair. So we get -2 comma -1. And as always, you want to check. The way you check is very simple. We use the first equation. Now you put it into the second equation to check your work. We want to solve this system of equations. First, let me call them equation 1, 2, and 3 because it makes life easier that way. Then notice that this has -4y, this has a +4y. So the first two equations, all you have to do, combine it. Notice we have 3 variables, which means we have to bring it to 2 variables. So you choose what variable to get rid of. It is easy to get rid of the y because the first and the second equation, you don't have to do anything. Just add them up. If you add them up, these two cancel each other. These two become 5x, 3z, +1. Now, equation number 3 hasn't been used, so we must use that. With which one? The first equation or second equation? It's your choice. Equation number 3 hasn't been used. It must be used. Which one do you use to get rid of the same variable, namely y? It's your choice. Makes no difference. Since this has a negative sign and this has a positive sign, perhaps it's a good practice to multiply this one by 3, this one by 4. When you multiply this one by 3, you get 9x minus 12y plus 6 equals -45. And you multiply this one by 4, you get 8x plus 12y plus 20z equals 18. Notice these two cancel each other. So add up these two, add up these two, add up these two, and it results in an equation. I'm going to call it equation number 5, 17x plus 26z equals 35. Equation number 4 has two variables, xz, and equation number 5 has the same variables. So we're going to put them next to each other. We have gone from a system of 3 to a system of 2. Now we have only x and z to deal with. We can get rid of the x by multiplying this one by 17, this one by 5, one of them negative. Or we can get rid of the z by multiplying this one by 26, this one by 3, one of them negative. So if we multiply the first one by 17 and the next one by -5, notice these two cancel each other. So we can add these two, 51 and -130. They add up to -79. So -79z, we add up these two, -158, divide by -79. And it gives you the value of z. Now we have to go back to either equation 4 or equation 5 that has two variables. We plug in z and we find the missing x. So this is 5x, this is plus 3 times z, which is 2, equals 1. This becomes 6. You take it to the other side. And that gives you -5. Divide by 5 results in -1. So we got x being -1, z being a +2. What is missing now? It's y. You have to go back to one of the original equations. For example, the first one, 3 times x means 3 times -1, minus 4y, plus 2 times z means 2 times 2. And that gives you -15y because y becomes a 4. You can work this out. -3 minus 4y plus 4. I hope you realize -3 and 4 is +1. take it to the other side, becomes -1 and -16 divided by -4 results in y being 4. Now, it's a good practice to put them in order as such, x, y, z. And since we used equation 1, now we should really check with equations 2 as well as 3. Equations 2 and 3 to check the work. Equations 2 and 3. That's the beauty of math. You can check your work. You can check your work, and you must do that. All right, we are given an inequality, a system of inequalities, and we want to solve there are different methods. The best method is to start drawing a boundary line by setting this one equal, regardless of the fact it's less than, greater than, less than or equal, greater than or equal, makes no difference. Set it equal, and all you have to do, pick up a couple of pairs and graph them. And remember, you set x equal to 0, y becomes -2. You set y equal to 0, x becomes 1. In this case, x is 0, y becomes 3, y is 0, x becomes 2, and you plot those pairs, you draw the two lines. As you can see, this is for the red one, this is 0, -2, this is 1, 0, connect them. For the blue one, this is 0, 3, and this is 2, 0, connect them. Going back to the original inequalities, this has the equality, therefore it's a solid line, this one doesn't. So that's a dashed line. So I want to make sure that everybody can see we changed it to a dashed line and y. Now we pick up a test point for each one, actually. The point 0, 0 doesn't belong to any of them, so that would be a good point. Otherwise, you can't pick it up. It shouldn't be on any of those lines. And so now check it with the red line. If you check it with the red line, that means you plug it into the original inequality for the red one. And 2 times 0 minus 0 is equal to 0. 0 is less than 2. Yes, this is a true statement. So 0, 0 works for the first one. That means what? This whole side gets shaded, and that is the solution for the first one. For the blue one, when you plug in 0, 0, I hope you realize 3 times 0 plus 2 times 0. 0 is larger than or equal to 6. This is a false statement. So this is the point, and this is true, this is false. Because this is false, if you look at the red one, because this is false, this side is not the solution. The opposite side is. So you shade them accordingly. This is red, this is blue, and they come together in this region. Notice there are 4 regions, 1, 2, 3, 4. So this is the region that is the solution for the whole thing. This one. Very straightforward. And those lines are called the boundary lines. A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. He's got 80% and 40% acid solutions. How many liters of each should he mix to get 10-liter mixture? This is a class of problem known as a mixture problem, everybody. You mix two things, as a result, the volume of each, they add up, the weights, they add up, and it's consistent. That's the idea. So you got to come up with a table. Your table has 80% solution, 40% solution, and a mixture, as it says here. So 80%, or you can say 0.8, 40% or 0.4. What about the mixture? The mixture is 48% or 0.48. So this is 0.8, this is 0.4, this is 0.48. Or you can keep it as a percentage, 80%, 40%, 48%. Now, we also know when we mix them, we get a 10 liters. So the volume is 10 liters here. What about the 80% we don't know? What about the 40% we don't know? So X and Y, because we want to go with the system. And the pure amount of acid or the actual amount of acid, if something is 80% solution, only 0.8 times X is pure, the rest is not. Normally it's water. So the product of this column and this column gives us the pure amount of acid, 0.8X, 0.4Y, 0.48 times 10. And that is a system we need. This one, X plus Y equals 10, that's the first equation, and this one 0.8X plus 0.4Y equals 4.8 is the second equation. And on purpose, I still put it as 0.48 times 10 because I want the reader to see precisely where the equations are coming from. And now you can do it by any method. It's you can multiply this one, by the way, by 100 to get rid of the decimals. It really makes no difference. In this case, we do the substitution. We solve for either X or Y. If we solve it for Y, it becomes the method we used in the previous module. So we're going to replace this Y with 10 minus X. And we are going to write 0.x. We are looking at the second equation, 0.x plus 0.4, and replace the Y with 10 minus X. The right side obviously is 4.8. When we distribute, we get 4 here minus 0.4x here. Bear in mind, when you multiply two numbers involving decimals and powers of 10, just ignore them, multiply them, and then count the number of decimals, count the number of zeros, see which one you have more of, and consider those. So with that being the case, 0.8x and minus 0.4x, they add up to 0.4x, and a positive 4 goes to the other side and becomes negative 4. We have 0.8. Divide both sides by 0.4 and x becomes 2. If x is 2, y must be 10 minus that, or 8. Therefore, x is 2 liters of 80% solution, and y is 8 liters of 40% solution. So when we say mixture problem, pay attention to consistency. The total volume is consistent and remains unchanged as 10. A plane can travel 800 miles per hour with the wind and 720 miles per hour against it. We want to find the speed of the wind as well as the speed of the plane in still air. In general, when we go in the same direction as the wind or the current, if we are in the water, the speed of the wind, the speed of the current will help us in the same direction, will be added to our speed, and it will work against us if we go the opposite direction. Therefore, first and foremost, your variables. You can go with X, Y, Z, you name it, whatever variable you want to choose, M, U, you name it, but sometimes initials work out better. So P represents the speed of the plane, W represents the speed of the wind. So a plane can travel 800 miles per hour with the wind. So that means P plus W, 800. And against it, that means P minus W. Okay, those are the two equations. I want to make sure that everybody's clear as to what's happening. You don't have to do much, just drop the W and minus W. You end up with P and P, which is 2P. And the right side, they add up to 1520. Divide by 2. And P becomes 760, and write the unit 760 miles per hour. And put it into any of those two equations. And the wind has a speed of 40 miles per hour. Admission tickets to Little League is $4 for adults, $1.50 for children, and we have a total of 225 tickets. We collected $500. We want to see how many adult tickets and children tickets. We are going to set up a system of equation. Again, it's a sort of a mixture problem, everybody. So here's the table. Adults, the cost of ticket is $4. Children is $1.50. How many tickets is the number of tickets? We know total was 225, and we know we collected $500. So whatever you want to put, X, Y, Z, again, whatever variable you choose, I'm going to go with A and C. A represents the number of adults, and C the number of children. Therefore, the total amount we collected from adults would be 4 times A, 4A. From children would be 1.5 times C, 1.5 C. And now we have the first equation, A plus C is 225, and second one, 4A plus 1.5 C is 500. And as long as we have those, we are pretty much in a good shape. All right, you can do it by any method. You can do it by substitution. For example, you can solve for A or C and put it in here, or you can do it by addition. It doesn't matter. If I multiply the first one by -4, this becomes -4A, this becomes -4C, and -4 times 225 is -900. We're going to just repeat the second equation. Those two cancel each other. These two add up to -2.5C, the right side, -400. We are going to divide both sides by -2.5. And this is the same as, by the way, negative over negative is positive, so it's the same as writing 4,000 over 25. And I hope you know that 100, if you drop 2, and this one gives you 4. So 4 times 40 is 160. That's how you arrive at the answer. Without a calculator, you can do it fairly fast. If C is 160 and the total is 225, then A would be 225 minus 160, which gives you 65. Bear in mind, we use this one or this equation to come up with the second variable. You must check with the second equation. In other words, you want to multiply 4 by 65, 1.5 by 160, make sure the total is $500. Check your work always. All right. The measure of one of the small angles of a right triangle is 50 degrees more than 4 times the measure of the other small angle. Find the measure of both angles. First, let's give them names. The small angle, let's call it A. The other one, let's call it B. And of course, right triangle, that means one of them is 90 degrees. So if we were to do the drawing, and this is not necessarily to scale, then here's A. Here's B, and here's the 90 degree, roughly. So let us write a couple of equations. Number one says the measure of one small angle, and we called it A. So A is what? 50 degrees more than 4 times the other one. So 4 times the other one is 4B plus 50. The other one is that we should know they add up to 180 degrees. So A is 4B plus 50, and the total interior angles is 180 degrees. A substitution will do the job. We replace this A with 4B plus 50. 4B and B, 5B, 50 and 90, 140. Subtract the 140 from 180, you get 40. If you divide 40 by 5, B becomes 8. Degrees. If it's 8 degrees, what is A? A is 4 times that, which is 32, plus 50, which makes it 82. Notice also they do add up to 90, because with this they must add up to 180. So always check with the next or the second equation in this case. Check and recheck. The difference of two complementary angles is 10 degrees. Find the measure of the angles. First and foremost, again, let's call them X, Y, A, B, you name it. But what matters is, what is the meaning of complementary angles? The two add up to 90 degrees. That's the meaning of it. Now, their difference is 10, so A minus B is 10. So this has this definition. We don't have to do much, just add up the left side, the b's cancel out. We have 2a equals 100, and therefore a becomes 50. If a is 50, then b must be 40 degrees. So a is 50 degrees, and b is 40 degrees. Two angles are supplementary. The measure of the larger one is 30 more than twice the measure of the smaller one. We want to find the measure of both. Again, let's call them A and B, X and Y. You choose what you want to go with. What is the meaning of supplementary? The two add up to 180 degrees. So that's one of it. The measure of the larger one, let's assume A is the larger one, is 30 more. That means 30 plus twice the measure of the smaller one, 30 plus 2b, or 2b plus 30. So again, in this case, this means this. Substitution will do the job. Replace the A with 2b plus 30. 2b and b gives us 3b. Subtract the 30 from 180 gives us 150. And divide by 3, b becomes 50. If b is 50, then the other one must be 180 minus that, or 130. And you want to check, making sure that it works here. If you multiply it by 2, 100, add 30, it's 130, or if you add them up, you get 180. In other words, check and recheck with both equations to be on the safe side. A rectangular garden has a perimeter of 140 centimeters. The length is 10 centimeters less than 4 times the width. Find the length and width of the frame. So it's a rectangular garden in this shape. The width and the length, here's the width, here's the length, and the perimeter P equals 140. So P is 140. Here's the width, here's the length. So we know the perimeter is 140. So right away, you add up 4 sides. That means 2w plus 2l, or you can say 2 times w plus l is 140. So that's the first sentence. The second one, length is, so L is equal to 10 centimeters less than 4 times the width. So 4 times the width is 4w minus 10. So this is the perimeter, and this is the second sentence. Now we are going to solve this. To solve this, you have 2 choices. You can distribute this and then move on. Or notice it's easier to not distribute that and get rid of the 2. How? If you divide both sides by 2, the 2 goes away and this changes to 7. And so now you don't have to do much but replace the L with 4W minus 10. So this results in 5W, and negative 10 moves to the other side, positive 10 and 70 is 80. Now the width is 80 divided by 5, divided by 5. That is 16. And the length is 4 times that, 64 minus 10 makes it 54. So the width is 16 centimeters and the length is 54 centimeters.